Okay, check out this next problem. Let's start not by graphing it, but by factoring, because that's always a good place to start if you can. There's a GCF in the numerator. It is x. That gives us x minus 1. There's a GCF in the denominator. It is 4x. That gives us x plus 1. And we can cancel a factor out, and it may not be obvious, but we can cancel this x with this x. And that leaves us with x minus 1 over 4, and then x plus 1. So let's find out, let's close parentheses. Let's find out what happens as x approaches negative 1 from the left, x approaches negative 1 from the right, as x approaches negative 1, as x approaches 0, and as x approaches infinity. All right, there's a lot going on here. Let's begin to look at the graph of this one, and I have graphed it right here. It's showing up in red. And we see a vertical asymptote at x equals negative 1, which makes sense. X plus 1, if x plus 1 equaled 0, then we would have a vertical asymptote. Then it would not exist, and therefore we have a vertical asymptote. So as we approach negative 1 from the left, the output is infinity. Notice we're approaching negative 1 from the left, we reach infinity. As we approach negative 1 from the right, we reach negative infinity. So as we approach negative 1, well, we've approached two different values, both of which are different types of infinities, positive infinity, negative infinity. So this one does not exist. Now let's approach 0. Now, if we wanted to plug in a 0 from the very beginning, we couldn't do it because there is a hole in our graph at 0. And if you look closely enough, actually the hole does show up on this calculator, on this graph, because it's centered perfectly at 0. It is very hard to see, but there's a tiny little gap right there in the graph. You may not be able to see it. I see it, but it may not be showing up on the camera very well. Nevertheless, I want to know what happens at 0. Well, I'll tell you what happens at 0. There's a hole. Well, where is the hole? What's the y value of that hole? Because as I approach, what am I approaching? We could go to the table and find out. So we could plug in numbers that are very, very close to 0, like, let's see, 0.01, 0.001, 0.0001. You see it? You see what we're approaching? All right, let's try this from the the negative side. Negative 0.01, negative 0.001, negative 0.0001. So whether I'm approaching from the left or the right, I'm getting close to a value of 0.25. What I could also do is actually plug in a 0 here. It's not wrong. At this point, we have reduced it to where the thing that would cause us to divide by 0 is gone. That factor is gone. So we can go 0 minus 1 over, plugging it in here, 4, 0 plus 1. And that gives me negative 1 over 4, and that's going to give me negative 1/4, which is what we just saw. Okay, I wrote that in blue. Everything else was in black. I apologize. It messes up the whole color scheme, doesn't it? White out and start over. Now, as x approaches infinity for our function, I wonder what the leveling off would be. And that leveling off is a horizontal asymptote. So let's find out. Let's go to the graph. I want to know where this levels off. Well, the last graph, the previous graph, leveled off at 2, and that's not it. We can keep taking guesses. Maybe this one levels off, whoops, at 1, and that's not it. And I hope you see why that's not it. Notice where they cross right there. And I'm going to zoom in a little bit. Let's zoom in at the origin so you can see the intersection a little more clearly. See? There it is. So that's not it. Well, maybe we can go down to a half. Let's try 1/2. Maybe it levels off at 1/2. I don't know. I don't know about that. If we go a little bit further to the left, actually I do know about that. I'm just not telling you. If we go a little further to the left, oh, notice where they cross? Oh my goodness. All right, let's go down a little bit more. Let's go to 1/4. You're probably bored waiting on this. You may already know the answer. There it is. Okay, it is at 1/4. Notice what else I just noticed? That hole in the graph is showing up even though it's not centered at 0. Interesting. Tricky little calculator. So the answer to this is 1/4. Now, if you're like, how in the world would you know that? Where did you get that? What in the world? How did you guess that? I'll tell you exactly how we guessed that. I'm glad you asked. Let's go back to this one for a second. This one is 2. You know why it's 2? Look at the very beginning. 2x squared and x squared. If I have enormous values of x, then subtracting 12 and subtracting 8 are irrelevant, okay? It is not legal to just cancel them out and say they're gone. But for enormous values of x, they are insignificant. And for enormous values of x, minus 2x and minus 2x are insignificant because the most important thing, the term that carries the most magnitude is the x squared. We're just going to look at that. If I have 2x squared over 2x squared, and I ignore everything else, because large values of x are irrelevant for this when compared to that. That's huge, insignificant. These are the little decimals that make it round to 2. This is what makes it 2. 2x squared over x squared. Let's do the same thing here. For enormous values of x, or incredibly negative values of x, subtracting x and adding 4x are insignificant. If I said, hey, 1,000,000, you have 1,000,000 squared minus 1,000,000. If I have 1,000,000 squared minus 1,000,000, I pretty much have 1,000,000 squared, you know. We'll subtract, we'll take those off just for the sake of our argument, and we'll say, well, I have x squared over 4x squared. Well, that's 1/4. 1/4. All right, that's a little shortcut. We're going to carry that as we move forward.